guys, so today we'll be starting the data structures video series, Java data structures. So today we'll be discussing linked structures stacks. So we'll be doing a linked stack implementation using Java. So there is a diagram that goes with this video. So if you're learning how to do stacks, so if you're learning about linked lists, linked structures, and you know arrays, well, it doesn't matter if you know arrays, but if you're learning about linked structures like linked lists, linked stacks, we'll be doing trees later too. But the first thing I would do is try to make a diagram out of your code first, because that's the best way to visualize it, is the best way to learn. Because if you just try to do it just by looking at the code, you're not going to understand how the nodes are actually moving and where the pointers are going. So you're going to have to actually draw the arrows out. So first we'll just start. I'll try to do the diagram before this part. But if you see this, if you watch this after, just forget what I just said. So, because I'll probably compile the diagram at the end of this, at the beginning of the video actually. So first, this video also will be on, we'll do some debugging. This might be a two-part video, because it could take a while, but it'll show you how to debug. I'm using IntelliJ. You can use VS Code as well. I wouldn't recommend Eclipse. It's pretty bad. It's like pretty slow. It looks really old. Like it looks like it's from the 90s. It's not very attractive as like a software designer, because it looks really bad. It's really boring. The buttons look really old. Same with NetBeans. If you like it, you like it, but personally, for me, it doesn't look very good, and it's slow. So every time you type something, it can lag. So I'd recommend IntelliJ, or if you like VS Code, use VS Code. But for some reason, the Java Sense packages or the add-ons didn't work, so it wasn't giving me any if I typed something, it wouldn't give me any options. Like it wasn't showing anything at all. So I'm not sure if there was a glitch when I installed it a few years ago. But so we'll just start with I haven't done a tutorial on how to install IntelliJ, but I'll try to do that. If not, just try to Google it. It's not that hard. And so after you do that, we'll just start with the linear node class. So we'll just say public. We'll create a class. So public class linear node, and we'll be using generics. If you don't know them, it's not that hard. Just practice with it, and you'll get it. It's actually pretty easy, and once you use it, you'll be using it all the time. So public class linear node of generic type T. Actually no, this is main, sorry, so we're gonna have to create a new class. So linear node dot Java. Of generic type T, it didn't do that. Okay, so we'll start with some instance data. So instance variables. So we'll create a object reference variable here of type linear node of generic type T, and we'll call it next. So right now it's just it's equal to null right now, I believe. And we'll say private T element, so that's a generic type there. The type of the variable is T. That's it. So each linear node object is going to have a next field and a element field, where the element can be any type. When you instantiate it, it could be string, object, it can be the wrapper class, integer with a capital I, double, float, whatever. And then here we'll create the constructor, so public linear node, parentheses, we'll pass in T element, so each linear node object is going to have an element that it's going to be instantiated with. In this code it'll be a number, but you can use a string or whatever if you want. So we'll say this dot element equals element, and then we'll set next equal to null initially. So in a linked list, we did this in the diagram, but each linear node object has an element field. Think of it like a box, and in the middle there's a line which divides it into two parts. So it's like a box with a line in the middle, and on the left side we'll have element, and then in the right side we'll have a next. And for example, in the element we'll put like a number like 5, and in the next reference gonna, in a linked list is, or in this case a linked stack, is gonna point to another node. So each box with a line through the middle is a node. A node is, it can be like a memory location. So a node is stored in a memory location. So beside the node's name you can have like some kind of like hash number or something, like just any number like 1135 or something, and the next node you create could be like 1136. You'll see in the when we debug it what I mean, but that's okay for now. So that's the constructor here. So I guess we're gonna overload the constructor, so we'll create a public linear node again. No parameter. This dot element equals to, element equals to null, and next, or think of it like this, next points to null, so the equal sign. A good way to start learning about linked lists is to think about the equal sign is points to. And like in C programming there's pointers, but in this way it's going to help you understand a lot more if you say next points to null. So currently next points to null. If you don't know what null is like doesn't point to an object. So it's basically pointing to nothing. That's basically what it's saying. And it's not 0, so don't get confused with it equaling to 0. So just think of it that it doesn't point to an object. That's what null means. Should probably do some annotations here, so could switch these, or here I'll just say constructor creates an empty node or linear node, and then constructor here will say overloaded constructor. That's fine. We could do some Java doc right now, but it might take a while. I guess we could. So we'll say it creates a node storing the specified element at param element 2. So element to be stored. So that's the parameter, and then pretend there's a comma here. So it's just saying element is the element to be stored. That's it. So here we'll start with the getters and setters. Or they call them accessors. Getter is an accessor method and setter is a mutator method. So create some more Java doc here. We'll say returns the node that follows this one. Whoops. Drop some. Okay, excuse me. Drop the mouse. So returns a node that follows this one. At return reference to the next node. At return reference. At return reference to the next node. This is from a book. I've modified some of it. Java Foundations. Some of these annotations don't make sense, so if they don't make sense, just ignore it. So we'll just say a public linear node of generic type T get next. And we'll just return next. Then here we'll say some more Java doc sets the node that follows this one. Sets the node that follows this one at param node to follow this one. So public void setNext takes a parameter because it's a setter, so linear node of generic type T node takes a node of type linear node of generic type T, and then we'll say next points to node now. We're going to be using that one a lot. In other implementations, you don't create this method, or you don't have to create this method. You can just set next, like manually, which is what like Telesco, that guy, he does computer science videos on Java and like other languages. He doesn't use setters and getters, so he just does it. He just does each one manually. So if you want to see that, check it out later. I don't know him, but if you just want to see how he does it. it might help as well. This is a different, this way we use getters and setters because in programming, in like bigger applications, you're going to be using getters and setters instead of setting each thing manually all the time. It's gonna get confusing that way. So using the setters can be easier to manage if you're managing like thousands of objects and stuff. So then we'll say the next one we'll say setNext. So we did setNext, getNext, and we'll do some more Javadoc here. Sets the node. Actually no, sorry. We already did that. Returns the element stored in this node. At return element stored in the node. So public T returns a value of type T, get element, public T get element, and then we'll just return element, because element can be anything because it's generic. The best way to learn generics is just to try. Trial and error. Like for example, if you're trying to return something and it's giving you an error, try T, or like try different things, and you'll, if I come across, I'll show you an example. So setNext, get element. setNext, let's just see what we have again. So we have two constructors, instance data, two constructors, get next, setNext, get element, and then the last one will set element. So Javadoc again, then we'll say it sets the element stored in this node. At param element to be stored in this node. Didn't close this one automatically. Okay, good. Public void set element takes a parameter T element. Oh, we forgot the interface. We should do that next. So we'll say this dot element equals to element. So we do that up here. Set get. Nope. That's fine. 1, 2, 3, 4. That should be fine. We're not going to use these really. We're just going to be using setNext mostly. So save that. Then we'll create a new class. Actually, we'll create a new interface. Where do we even have this? Somewhere. If you've seen the previous videos, it's in the array implementation. It was called StackADT of generic type T. One sec, I'm just looking for it on my other computer. Generic slides, no. I had it in a text file, but for some reason it's just blank, so I must have deleted it by accident. Should have it here somewhere. StackADT, yeah, here it is. So it's just called StackADT like that. .java. Public interface StackADT of generic type T. So here we'll just say it just defines the interface to a stack collection. So it defines the interface to a stack collection. Public interface StackADT of generic type T. So we'll do some Java doc again. So adds the specified element to the top of this stack at param element to be pushed onto the stack. So this is for the push operation or method. So push method, public void push, takes a parameter t element. And then remember, in an interface you have to include the semicolon after your method. And there's no brackets. So this one removes and returns the top element from this stack. Return the element removed from this stack. That's for public t pop. Reason why it's t is because it returns the element. You don't have to, but it's good to do that. You could just make it void if you really want to. So the next one for peak is return without removing the top element of this stack. Return the element on the top. Whoops. Return the element on top of the stack. So public t peak. So it doesn't modify. Peak doesn't modify anything, it just returns a reference to the top element of the stack. The next one is a boolean is empty. So returns true if this stack contains no elements. Return true if this stack is empty. Excuse me, so public boolean is empty. Whoops. Is that it? No, one more. Actually, two more. So returns the number of elements in this stack. at return the number of elements in the stack. That's public int size. Just like that, and then public string to string. We don't need to write anything for this. Whoops, did I do that in Java doc? We could just say at override. We'll just do it in Java doc, so we'll just say at override. To string, or we'll say objects class. Whoops, object classes. Is that wrong? Classes to string method. We'll say public string to string. Almost wrote that in French, I think. Okay, so that should be okay. Just save that. So if you don't know what an interface is, it just helps us. It's like a blueprint basically for a class. So some classes need certain methods and they have to return something. So it just helps you. It actually makes sure that your methods are returning the right things and they're accomplishing what they're supposed to do. And it has certain methods in it, stuff like that. So after that, we'll create one more class. I think it's just a linear stack, or link stack, sorry. Where do I have it here? Okay, so it is, okay, here, so we'll call it linked stack. Link stack.java. So public class link stack of generic type T. I don't know why the font is so small on this. And then here we'll put implements StackADT of generic type T. We should get an error there because it's going to say we're supposed to implement these methods. So we'll start here with creating some instance data as well. So we'll create a private int variable called count. It's just going to keep track of our elements for the size. So we'll say and then here we'll create a object reference variable. Linear node top. Linear node of generic type T. Top. So it's going to just keep track of the node that's at the top of the stack at all times. It's going to help us traverse the stack. And actually, the way the book did this code is that they called it next, but it's really previous and I forgot that I was going to change it. But it's actually going backwards, it's not going forward, so it's technically a previous reference. So if you don't know what a doubly linked list is, a doubly linked list usually has a next reference and a previous reference. So it has two links, one next and one previous, and there's usually like a head node or a front node, and they also call it a head node. I usually just call it head node. And then they also have a rear node, or I call it a tail node. I think most people just call it head and tail. And it has a next and previous, but for just a singly linked list, which is what we're using, but it's actually a linked stack because we're supposed to look at it up to down, but you can also look at it sideways from left to right. So on the left to right diagram, usually the element on the right is the top of the stack, and down to up, usually the top element is the top of the stack. So technically it's going backwards, so it's actually a previous reference. It's not a next reference. But since we already wrote it this way, we'll just keep it that way. So here we'll just say it's a top node. And then we'll just do some doc again. So we'll say creates for the constructor. So we'll say creates an empty stack. So we'll just say public link stack. No parameters. We could have created one that will pass element in, but we don't need to right now. So we'll just set count equal to 0 and top points to null. So when we create a link stack object in main, count will be set to 0 and top will be initially pointing to null. So again, null just means that it's not pointing to an object. So here we'll just say public void push. The push method takes a t element, and we'll say linear node of generic type t. We'll call it, so we're going to create a linear node here. So we're going to create a linear node of generic type t object. We're going to call it node, and we'll set it equal to new linear node of generic type t, and we'll pass in element as a parameter. Because remember here, in the constructor that takes a parameter, it takes an element. So here we created a linear node that takes an element, and we're creating the element that we're passing in is the element that we're going to push onto the stack. So the parameters are being passed from the constructor to the method, or from the method to the constructor. Then we'll call node.setNext to, we'll pass in top. So node.setNext to top, and then top now points to node. And then count plus plus. So again, if that's confusing right now, we'll see the diagram, so that will help you understand. But all we're doing is, so we're pushing, let's just say we're pushing the element 5 onto the stack, or you can push a string, whatever. So we'll say linear node of generic type T node. So here we're whoops. Well, this is object creation, right? We're instantiating a linear node object. We're calling it node, and we're passing an element. So here we're saying node.setNext. So what are we doing in setNext again? So setNext takes a parameter here, linear node of generic type T. We call it node. So remember, each linear node object has two fields. It has two instance data, right? So it has a next reference and an element. So when we create this object, the element is being passed here. So now that's the element for this linear node, which equals to 5. And we'll say that the next reference of the node is now pointing to top, and top is pointing to null. So again, with the diagram, this will all, you'll see how it works. But then after all that, we're saying now top, which is a global variable for this object, which is the link stack. So the global variable is now the top global variable. It's now pointing to the node that we just created. So top points to the element 5. And next for top is pointing to null, which is, and now top is this. So this next reference for this node right now is pointing to null because it's the only object in our link stack. So again, see the diagram, and that'll help. So public T pop, I think I changed it from what the book was. What did I change it to? Excuse me, so I'll just do what the book did first. So T result points to top.getElement. So here we created a variable of type T called a result, and we're pointing, so it equals to, or it points to the top variable, the top node. Right now technically the top node is 5. The element that it's holding is 5, so the get element is 5. But if we're popping just one thing, it's not really useful, so we'll just we'll do the explanation after. So we'll say top points to top.getNext. Count minus minus, and then return result. So imagine there's 5 and 6 on the stack. So the top element is 6. So we're saying T result points to top.getElement, which is 6. So now top points to top.getNext. So it's the next reference. Like I said, it's technically a previous reference, so it's pointing to the object below it or beside it. So it's actually pointing to 5. So top now points to top.getNext. So top now points to 5. Count minus minus and return result. That's what they did. What I think might be better, would help you save memory if you're, for example, storing lots of data and you want to save memory, that we could possibly change it. So we could say, here we can create a object reference variable, linear node of generic type T temp. We'll set it we'll set it equal to top. So we'll say linear node of generic type T temp points to the current top, which is 6. Just imagine there's these elements on the stack right now. So then t result is the same. Top points to top.getNext, that's the same. So linear node generic type t temp points to top, which is 6. T result points to top.getElement, which is also 6, the element. Then we'll say top points to top.getNext, so top now points to 5. Then here we'll set temp equal to null. So we're saying, so temp, we created a pointer here, so temp points to top. That was the first line. And at that current time, top was 6. So down here, after top changed to 5, we're setting that original top, which was 6, we're setting equal to null. So we're deleting it from the memory, so that way it could help us save space, or save memory overall. Because I think after the object reference variable that's pointing to null, it will be taken to garbage collection, I think. So it should, but either way it's not pointing to anything, so it's saving space already. So that should work. We can debug it after. I might do a debug in the second video because this is already taking 40 minutes, so we'll do the next one. Just a few more easy ones. Those are just the hardest ones, and then these ones are easy. So then public t peak. Then we'll say return top.getElement. That's easy, right? We're just returning the top variable's element. The next one, public boolean is empty. We'll just say returns true if count is less than or equal to 0. So if you don't know what that means, here, like before when I first started, I used to say return true if this, else return false, but here this is just a faster way, so it just says returns true if count is less than or equal to 0. Then we'll do public int size. We'll just return count. And public string to string. We'll just create a string variable here. We'll set it equal to an empty string. Then we'll say linear node of generic type t top temp points to top. So it's like a traversal here. So we'll go over it after. So while I just call it temp. So linear node of generic type t temp points to top, while temp does not equal to null. str equals to str plus top temp dot get element plus new line. Whoops, just temp, or yeah, just temp. Whoops. So it's just a concatenation. This empty string plus equals to this empty string plus the element plus a new line. So it's gonna print it out in a stack. When it's gonna display it as a stack, so like each line, each element is gonna be on a new line. Then we'll say top temp, or just temp, points to top temp, or no, sorry, temp just points to temp dot get next. So temp equals to temp dot get next. then return str. That's it. That should be all. Then just go to the main method. So I'll just write it here, public class main, public static void main, string array args. Just lagged a little bit, IntelliJ did, but doesn't happen that often. If you're using VS Code, that happens almost every time you hit space. That's why I switched. So we'll create a link stacked object here of type integer object. We'll call it link stack lowercase equals to new link stack of type integer object. Empty parentheses. Then we'll say link stack dot push. We'll push 5 onto the stack. Then we'll say link stack dot push 6 onto the stack. You can push whatever you want. You can instantiate it to strings if you want, and type some strings. Then we'll push 11, and then we'll system.out.print ln. We'll print the link stack. Save it and run. There's probably a error somewhere, we'll just fix it. Okay, so there's no errors, so 5. So you can see we push 5 onto the stack first, then we push 6, and then 11. So you can see 5 was the first element that we pushed. It's on the bottom of the stack. So the top should be 11. Wondering if I should I guess I should just do it now. So how to debug. So we'll just set a breakpoint here. Just click there to set a breakpoint, and then click the debug button at the top. Wow, it's really small. For some reason the font size is small. Editor, general. Is there a bigger font size here? Font here, font. Size, can you give me 30? I have a feeling that's not going to change that. Yeah, it did. I need the whole interface to change. Yeah, I don't think that's going to help, so hopefully you can see that. So there's buttons here: step over, step into, force step into, step out. So we'll step into this line here. So we're instantiating a link stack object. Step into, because if you step over, it's going to skip to the next line. Step into. So here we step into this line here. We're instantiating an object. You sometimes will have to step out because it's going to take you into the built-in code for Java. So right here we're in the constructor now. So we've created a link stack with no parameters. So now we're here. We're in the only constructor in link stack. So here, if you can see, it says this. Click on it and you can see that each link stack has two fields. Count, which is set equal to 0 right now, or it's initially 0, and top, which equals to null. Step into here. We're gonna explicitly set count equal to 0, and then top now points to null, and the constructor is done. The object has been created. So now we're here, link stack dot push the element 5, step into. So here we're going to see our node get created here. So linear node of generic type T node equals to new linear node of generic type T. Pass in element as a parameter. So when we said push, we pushed 5. So push link stack dot push 5. So now we're creating a new node here, and we're passing in 5 to our linear node constructor. So here we're going to go into the constructor now. So click step into linear node object creation. So we're going to go into the linear node class, the one with the constructor that takes a parameter, not the one that doesn't take a parameter. And it knows that because there's only 2 and 1 takes a parameter, so it's obviously going to be this one. So now we're here. So it took an element which is 5, so we set this, so each linear node itself has a next and an element field. It has that instance data, which is a next instance data, and an element instant data, so each object has a next field and an element field. So this dot element equals to element, so the object's instance data for element is now set to 5. And the next reference still points to null. So the node is created, and here we can see that memory location that your computer has created. So the JDK has created or created bytecode and machine code, and in all that, it's saving the node as a so the memory location for this, where the node is held at, is right here, 956. So now the node, if you click on it, it has the next points to null and an element which has its own memory location within that memory location. So here we're saying node dot setNext to top, and top equals to null, I think. So we have our this instance data for the link stack, global variables, right? Count and top. Count equals to 0, top equals to null. We had our element that we passed in, and our node. So node dot setNext to top. Step into. Next points to node, the node that you passed into. So the linear node's next reference now points to the node that you passed in, which was top. So now you can see, so if we go back, public void setNext linear node takes a parameter. I think the formal parameter is linear node of generic type T node. So the node was actually top, the global variable top. So next, so the node that we just created right here at 956 points to, so the node at 956 that we just created, its next reference, because each node has a next reference, now points to top, which points to null. So it's still pointing to null. It's still unchanged. See the diagram? Then we're saying now top points to node. So the global variable top is now pointing to the node at 956. So the one and only node we have in the stack, that's where the top variable is pointing to. We can see that here by clicking this, our instance data for our link stack. Count equals to 0, top equals to linear node at 956. Right there. So top points to, so the top reference for our stack, our object reference top, points to the only node 956. Count is incremented by 1. That's it. We pushed 1 onto the stack. We'll just push one more, just to show how it changes again. So it's going to be different this time. So link stack dot push 6, the element 6. So we're going to link stack dot push. So we're going to create another new node here, linear node of generic type T node. Points to new, so it's object creation. We're instantiating a new object. And we're passing in element as a parameter. We can step into this as well. So the constructor for a linear node takes an element, we pass in 6. So this dot element points to the element that we passed in. And next points to null. So remember, every linear node has an element field and a next. So an element reference and a next reference. A reference or a field, whatever, instance data, you can call it whatever you want. We'll just say that it has an element field and a next, or a null field. So after that, so we just created a new linear node object, and this one is at 990. It's not at 956. That was the first one. This is the second one. The second one is at 990. So node.setNext. So node.setNext to top. So step into, so we're setting the node that we just created. Its next reference is being set to top. So setNext takes a parameter. So top, remember, it's pointing to currently, it's pointing to at, it's pointing to at 956. Where is our top? disappeared. So right now top points to 956. So the next reference for the new node is going to point to where's 996? Or sorry, 990. The next reference now points to 956. So remember, the next reference is actually technically a previous reference because it's pointing backwards. So here we're setting linear node, we're setNext. So we're setting the node at 990. Its next reference is pointing to top, which at this time is at 956, the first node that we created. So set the new node that we created at 990 to point to at 956. So it's pointing console. No. Think of it like this, like how we saw 6 and then 5. 5's the first item, the first element that we created. 6 is a second. So now 6 is pointing, its next reference is pointing backwards, or down is pointing to 5, the first one that we created. So that's done. Then we'll say top now points to node. So top now points to the node that we just created at 990. We can double check that here by looking at our global top variable, and we can see that it points to 990. Count plus plus. We'll see count equals to 2, and we can see our stack here. So we'll see the top is pointing to the element that we just pushed on at 990. And here's how the linked implementation works. You're going to have to click the next reference of it, and it points to the next element in the linked list. So here's, in our link stack. So in our link stack, this is our link stack right here. Top element at 990. It's holding 5. Whoops. So, our top element at 990. It's holding the element 6. And its next reference points to the node at 956, the linear node at 956. Its element is 5, and its next reference points to null. So the more you add, the bigger the link stack becomes, because more objects are being pushed onto it. So that's it. We'll just skip that one. You get the idea. And it prints out right here. We can stop it, and then we'll just do a pop. So link stack.pop. I don't think it takes parameters. Yeah, it doesn't. So we'll go to main, we'll change that breakpoint, we'll put it down here. We'll click the bug to debug. So we're exactly where we left off. Actually, no, with one more. So you can see top points to 11, 11 points to 6, and 6 points to 5. So we'll step into that. So we're setting a linear node of generic type T temp, an object reference pointing to top. So right now top points to at 983. And by the way, if we ran it again, the numbers will change probably. So we have 11 is 983, 6 is 984 and 5 is 986, I think. So we're setting temp. So we're saying temp points to top. So after we step into this, we can step over it as well, same thing. So temp should point to at 983, which is holding 11. Temp points at 983, holding 11. So we've confirmed that it's working. So then we've said here, so now we're saying tResult points to top.getElement. So tResult points to 11. Top points to top.getNext. So top points to, so now our variable top here is going to point to top.getNext. So now top is going to be 6 after this, after we click this button here, step into. It's going to change. So now we can see top now points to 6 and it points to 5, but it's technically still in memory. So I changed it here so we can see our variable temp is still pointing to that 11. Right, that 11 is still there, as you can see, because we've created a memory location pointer to it. So it's still pointing to that memory location, and it's going to disappear here because we're gonna set it to null. So at 983, which points to the element 11, the linear node at 983 is going to disappear now. Gone. At 983, temp now points to null. We still have our linked list here, a linked stack. We have our top element, which is 6, and our next element, which is 5. So we have 6 on top of 5. And after 5, there's nothing. So count minus minus, return result, pop, print out the stack, console. There you go. So I hope that helps, and I'll see you guys in the next video. Take care.